complex rational expression. What is a complex rational expression? We know what a rational expression is. So what's a complex one? That's when you have a fraction divided by another fraction, like 2/3 over 5/7. And the question is, how do we simplify this? Well, if you look at it, it says 2/3 divided by 5/7. That's what this one is telling me to do. Take the top fraction divided by the other fraction. Well, we know how to divide. We switch this to multiplications, and we do the reciprocal of the second fraction. And now we multiply that. That's 2 times 7, which is 14, over 3 times 5, which is 15. Another way of doing this, actually, if you have just a fraction divided by a fraction, that's a shortcut, and that is you multiply the two outside ones. So it's the outside divided by the inside. So if you take the outside, what's 2 times 7? 14. The inside, 3 times 5, 15. The same answer. Quicker. Let's take another one. X squared plus 5. The whole thing divided, let's say, by 1/4. You can make that x squared plus 5. That's really over 1 divided by 1/4. Well, dividing by 1/4 is the same as multiplying by 4 over 1. And again, multiply the top times the top, 4 times x squared plus 5, divided by 1 times 1, which is 1. If you're dividing by 1, we're not going to write the 1 in the bottom. So that becomes my answer. Now, what are we going to do as these rational expression or the complex rational expression get a little bit bigger? An example. If I have x over 2 plus 1 over 2 over x squared over 3 plus x over 3. Well, what I can do is simplify the top and simplify the bottom, then divide them. So let's look at the top. If you look at the top, like this one, notice we have two fractions with the same denominator. So the bottom stays the same, and we add the two top numerators. Now let's look at the bottom. Two fractions. They have the same denominator. So keep it and add the two of them. And now simplify that. You can still use, if you want, to the outside over the inside. If I do the outside over the inside, that's a quick way to get to the answer. This is the outside, and this is the inside. So multiply the outside times the outside, and that will give me 3 times x plus 1. The inside times the inside, 2 times x squared plus x. And again, now you need to look and see if you can simplify that. Well, let's look at this. X squared plus x. Well, to simplify that, there's the 2 sitting outside. But how do you factor x squared plus x? Well, you can see it has x as a common factor. X times x plus 1. So x is the common factor to both of them. And now notice you have x plus 1 here, x plus 1 here. They do cancel each other out. And what's left is 3 on the top and 2x on the bottom. So this is one way of doing it. I'm not a big fan of that method. I mean, there's nothing wrong with it. I don't dislike it. I just think there's another method that's quicker than this. And that is, you look at all these fractions, all these individual fractions, all 4 of them. What is the LCD for them? The LCD is 6. So let's multiply every one of them by 6 over 1. And now let's simplify it. By 2 this is 1, by 2 this is 3. What's 3 times x? 3x. By 2 this is 1, by 2 this is 3. 1 times 3, which is 3. Over 1, you don't write the 1. By 3 this is 1, by 3 this is 2. 2x squared. By 3 this is 1, by 3 this is 2. Once you multiply by the LCD, all the little fractions are gone. This is actually the simplified version of this one. Now again, let's see if we can factor that. Well, out of the top group, I can take a 3 out. If you take a 3 out, what's left? X plus 1. Out of the bottom group, you can take a 2x out. And if you take a 2x out, what's left? X plus 1. And the x plus 1 cancels the x plus 1. And your answer is 3 over 2x. The same exact answer. I'm more of a fan of the second method, multiply by the LCD, because I don't want to deal with fractions. Once you multiply by the LCD, all the fractions will disappear. You end up with just one big fraction. Let's try another one. I'll try a few more actually, not just one. 2 over x divided by 6 over x cubed. And I'll show you both ways. I'll do them both ways. This will be 2 over x divided by 6 over x cubed, which is 2 over x times x cubed over 6. By 2 this is 1, by 2 this is what? 3. I can simplify the x's, I'll wait on that. 1 times x cubed, which is x cubed over 3x. Now the x's I could simplify. There's 1 x on the bottom, there's 3 on the top. So one of these will cancel one of these. That will leave me with the 2 of them here. So that's equal to x squared over 3. The other way of doing it, instead of this long, lengthy process, is the outside over the inside. 2 times x cubed is 2x cubed. 6 times x is 6x. By 2 this is 1, by 2 this is 3. One of the x's will cancel one of these, And what's left is 1 times x squared, which is x squared. X is gone, 6 is gone, there's a 3 left here. Same answer. Quicker. Let's try y over 2 plus y squared over 3. I can't really simplify the top, so I'll leave it alone. The bottom, if you want to add them, notice you have different denominators. You need to make sure you have the same denominator, which is 6 in this case. I need to make sure the bottom is 6 for both of them. So how do we turn the 2 into 6? We multiply it by 3. And if you multiply the bottom by 3, you multiply the top by 3. So this becomes 3 times y, which is 3y, over 3 times 2, which is 6. I need to multiply the 3 by 2 to make it 6, and that's by 2. 2 times y squared is 2y squared. So this becomes y over 3y plus 2y squared divided by 6. We have a division, which means this is actually is equal to y divided by the y is really y over 1. So you can change it to y over 1 times 6 over, I like to put this in descending power. I like it better that way. And now when you multiply y times 6, which is what? 6y. 1 times anything, it just leaves the fraction alone. Can you simplify your answer? Let's see. From the bottom, you can factor a y out. And if you factor a y, what's left? 2y plus the 3. And this y cancels that y, so my final answer is 6 divided by 2y plus 3. Now, I can't divide the 6 by 2 and the 6 by 3. Can't do that. Notice how many steps here. Let's watch the other method. I only have a little space here. That's y, or y over 1 if you want to, divided by y over 2 plus y squared over 3. What is the LCD for all three fractions? 1, 2, and 3. The LCD is 6. So I'm going to multiply this by 6 over 1, 6 over 1, 6 over 1. The top will be what? 6 times y, which is 6y over 1. I don't need the 1. By 2, this is 1. By 2, this is 3. 3 times y is 3y over 1. I don't need the 1. By 3, this is 1. By 3, this is 2. Y squared times 2, which is 2y squared over 1. I don't need the 1. Notice in one step, I went all the way from here, from this to that step, right there. I'm right here. So I bypass all of these. Notice this and this are the same. So that's why you can see I'm a fan of this method. Again, from the bottom, you can factor a y out. If you take a y out, what's left? 3 plus 2y. The y will cancel. It's 6 over, and I like to put them in descending power. And that's the same answer. One line. So you're going to see me from now on probably use this method more often than that one. Let's try this one. Simplify. Two x over x squared over 4 plus x over 2. My LCD now for the 4 and the 2 is the 8. And I'm going to multiply every one of them by 8, including the top. 8 times that. 8 times this, that's 8 over 1. 8 times this, that's 8 over 1. What is 8 times 2x? It's 16x. Here we go. By 4, this is 1. By 4, this is 2. What is 2 times x squared? 2x squared. By 2, this is 1. By 2, this is 4. X times 4, 4x. And now let's factor. I can factor 2x out of the bottom. If I take 2x, what's left? X plus 2. Simplify your answer. This x cancels that x. By 2, this is 1. By 2, this is 8. So my final answer is 8 over x plus 2. Simplify. 1 plus 1 over x, 1 minus 1 over x. My LCD for these two little fractions is what? It's x. So I'm going to multiply every term by x. Notice when it's a fraction, I always make it over 1, just to make it easy on you to multiply. But if it's not a fraction, I'm not going to say x over 1. It's the same thing as x. X times 1, x plus. This x cancels that x. That's a 1. X times 1 is x minus this x cancels that x. 1 over 1, which is 1. And that is my final answer in one step. I'll do another one just like it. Simplify. I can't. 2 minus 1 over n. 2 plus 1 over n. My LCD here for these two little fractions is n. So I'm going to multiply this by n, this one by n, or n over 1, this one by n, and this one by n, or n over 1. What is 2 times n? 2n. The n's will cancel. That's a 1. n times 2. 2n plus the n's will cancel. 1 over 1, which is a 1. I can't simplify these two. I can't cancel the 2n with the 2n. It has to be a multiplications. Simplify. Three plus 1 over x squared over 3 minus 1 over x. My LCD, I have x and x squared. It's the same term or the same factor, but We always pick the one with the highest power, so it's x squared. So I'm going to multiply each one of them by x squared. What is x squared times 3? 3x squared. Plus, this x squared, cancel this x squared. 1 divided by 1, that's a 1. X squared times 3 is 3x squared. Minus, there's 2 x's on the top, 1 on the bottom. That will leave me with 1x. I can factor an x out of the bottom, but it's not going to help me. So if I factor an x out, what's left is 3x minus 1. That doesn't really help me simplify anything. So this is good, that's also good, either one. Simplify. One over x squared minus 1 over y squared over 3 over x minus 3 over y. The LCD for x squared, y, and y squared. Remember, the LCD is the multiplication of all the different factors. So the different factors are x and y. And each of them is raised to its highest power. So the highest power of x is 2, the highest power of y is 2. I'm going to multiply everything by x squared, y squared. That's my LCD. When you multiply by x squared, this x squared cancels that x squared. What's left there is y squared. This y squared cancels that y squared. What's left there is x squared. Now this x will cancel one of these, so it still leaves me with 1x on the top. So that'll be x, y squared times 3, that's 3, 1x and 2 y's. Here's the 3. And this y will cancel one of the y's here. That will leave me with x squared and 1y. And now let's factor and see if something cancels out. I can factor the top as the difference of two squares. The bottom, what do they have in common? I think I see 3x and y, 1x and 1y. If I do that, if I factor 3xy out, there's still a y left here, minus still an x left here. And now this piece cancels that piece. And my final answer should be y plus x over 3xy. Let's try maybe one more. Simplify. One over 2a squared minus 1 over 2b squared, the whole thing divided by 5 over a plus 5 over b. And again, my LCD, I can see the LCD is 2a squared b squared. That's over 1. 2a squared b squared over 1. 2a squared b squared over 1. 2a squared b squared over 1. I'm multiplying each one of them by the LCD. The 2 cancels the 2. The a squared cancels the a squared. So I have what? B squared left. 2 cancels the 2. B squared cancels b squared. That's a squared. The a cancels one of these a's. I still have one more. What's 2 times 5? That's 10ab squared. The b cancels one of the b's. I still have another b here. 5 times 2, 10a squared b. And now simplify that. Maybe we can factor it first. B minus a, b plus a. LCD for the bottom is 10ab. If I factor 10ab, I have b left here, plus I have 1a. B plus a will cancel each other out. B minus a over 10ab. And that's how we simplify complex fractions.